Hello, everyone, and welcome to our presentation, Scaling Digital Preservation, Strategy, Infrastructure, and Sustainability at the University of Texas Libraries. My name is Jeremy Thompson. I'm the Digital Processing Archivist here.
My name is Vivian Nguyen. I'm a software developer here.
My name is Mirko Hanke. I'm the head of preservation and digital stewardship.
And my name is Karla Roig. I am the digital preservation coordinator.
Today, my colleagues and I will be speaking about the digital preservation infrastructure at the University of Texas Libraries that has been in place for over 2 decades and the ongoing renovation to address its limitations and growing need of its application. As our current digital preservation infrastructure passes 2 decades of service, it faces an inflection point brought on by a myriad of factors. These factors include an aging technical infrastructure and the reliance on manual processing that have hindered the scalability of our current system. Currently, our digital archive accounts for over 16 million digital files that are sourced from 5 producer units within the UT libraries. Our current practice for long-term digital preservation is for digital records to be written to duplicate linear tape open tapes, which accounts for the over 500 terabytes of data that we have preserved so far. With the increasing province of digital records, we recognize the scalability limits placed on us with this current system and the need to modernize and standardize our practices. This began a period of reflection as we undertook a systematic review of how digital records flowed throughout our organization. This also kicked off our search for a digital preservation management system, which we will speak about more today. Now I will hand it off to Mirko.
Thank you. We used the opportunity of post-COVID staff transitions to reassess our digital preservation workflows and infrastructure. We grounded that assessment in 2 key frameworks, the OAIS reference model, which helped us to describe our existing system as a socio-technical whole, and it provided a shared vocabulary. We also used the NDSA levels of digital preservation, which served as a benchmarking tool for our practices, and they helped us identify areas for improvement. We visualized our current workflows, we identified pain points, and mapped out an ideal future state system. And these visualizations became powerful advocacy tool, helping us to communicate complexity and risk to our leadership. From there, we moved into strategy development. We engaged stakeholders across the organization, from collection managers to IT to our leadership, to align on goals and scope. The result was a 5-year strategy document that outlines our priorities. First, automating digital preservation activities. Second, modernizing and scaling digital archival storage infrastructure. Third, increasing geographical redundancy of storage. Fourth, improving discoverability and management of archival content. Fifth, building, documenting and disseminating a digital preservation framework for our organization. And sixth, supporting stakeholders at UT libraries in their practices for digital preservation. If you're interested to hear more about our assessment and the strategy development, please check out our presentation we gave at the Code for Lib conference earlier this year. The talk is still available on YouTube. The strategic foundation that we built set the stage for one of our major initiatives, and that is the selection of a digital preservation management system. Next slide. We launched a 6-month project to evaluate options for a software system to support our digital preservation activities. We did assess 3 solutions in depth. One was Archivematica, an open source software solution, Preservica, a proprietary software as a service solution for digital preservation, and Ex Libris's Rosetta, which at the time was under development and I believe is now marketed as Specto. Our evaluation criteria that we applied included OAIS compliance, the support for automation and scalability, whether the tool allows us to manage metadata, the option for flexible storage architecture, vendor reliability, and ultimately cost. We recommended Archivematica to our leadership based on its alignment with our strategic goals, because of the strong community support and because of the flexible implementation options. It does require a commitment by our organization to provide staff and to maintain infrastructure, but it also offers transparency and control. We're currently in the process of implementing Archivematica with a hybrid storage architecture, and my colleague Vivian is going to talk a little bit more about our implementation.
Our Archivematica deployment is containerized and orchestrated using Kubernetes, is built around a modular architecture where each major Archivematica function runs in its own pod. These pods are the following: the dashboard web UI, which is where you log in, configure settings, start processing jobs, and also monitor their progress. The microservices control panel server. This pod is the brain that decides what needs to be done next for each file package, including extracting metadata, normalizing files, and creating premise events. We also have Gearman, which is the middleman that passes processing tasks between services. The MCP server sends tasks to Gearman, and MCP clients pull them from Gearman to work on them. The microservices control panel client, these are the workers that actually do the processing steps, transcoding files, creating AIPs, generating metadata, etc. And finally, we have the storage service, which manages where and how AIPs and DIPs are stored. It handles transfers to archival storage and retrieval when needed. It communicates with the MCP server to receive store retrieve requests. We chose to implement Archivematica in a containerized Kubernetes environment for a number of reasons. The first reason being modularity. Each component has its own pod or service. Secondly, vertical scalability. It is simple to change resource limits for pods and services based on their usage. For example, the MCP client requires a lot more CPU and memory, 24 cores and 16 GB, compared to the dashboard, which requires less than a core and 1000 MB. Horizontal scalability. We initially wanted to scale MCP clients up and down based on the load, but we found that some of the app and database logic does not have some concurrency save logic. Resilience. We can easily restart any crashed pods. Furthermore, one crashed pod does not crash the entire system. Resource, isolation, and monitoring. We can easily observe resource usage. We can also view any log output for each pod in the system. We have also implemented automation tool scripts designed to automate what's normally done through the dashboard. The scripts run as scheduled cron jobs that automate our ingest process. These tools watch two different transfer source directories for incoming standard and unzipped bags transfers. They move packages into Archivematica's workflow without needing manual dashboard clicks. It lets the user include predefined processing configurations, sends processing jobs to specific pipelines, and also deletes packages from the transfer sources after they have been fully ingested into Archivematica. Our implementation of the automation tools to pick up packages from the transfer sources and automate dashboard processes keeps ingest going without requiring our manual intervention. This means that ingest can continue to take place without anyone needing to click around manually during the process. As long as packages exist in the transfer source, their ingest into Archivematica is completely automatic. We mirror our AIP storage to both our LTO9 tapes and the cloud using the Zendata archive server software so that our data can exist in 3 distinct places to ensure long-term access, failure resilience, and disaster recovery. This configuration has enabled us to have a throughput of approximately 421 gigabytes into the Archivematica system per day in our test environment.
As the product owner of our digital preservation management system, Archivematica, I am responsible for leveraging my subject expertise on digital preservation, prioritizing project needs and overall project management, as well as liaising between our various stakeholders from libraries, IT developers, and supervisors to collection managers, archivists, and other staff members. Planning for the implementation of Archivematica has been a collaborative process across multiple units. Once the library's IT developers had provided us with a stable Archivematica test environment in June 2024, My stakeholders and I utilized it to familiarize ourselves with this new system, from delving deeper into the myriad customizations possible to making decisions on configuration settings. At the same time, our metadata analysts began working on consolidating, standardizing, and remediating our legacy metadata from the existing AIPs on our 500 terabyte tape archive. This process took 9 months, happening simultaneously with the developers building out our technical architecture. By March of 2025, Archivematica was set up in Kubernetes clusters, and it was time to perform load testing. This was a 6-month process where I needed to ensure that the system could scale up and sustainably and reliably handle the amount of material in our digital archive. Because it's been around for 2 decades, the ways that our packages have been created have changed over time. So our AIPs currently range from as small as a couple kilobytes and a handful of files to 5 terabytes and 2 million files in one single package. Our goal with load testing was to understand the limitations of the system based on our tech stack so as to inform our migration and implementation plans further. As of this September, when this is being recorded, we are currently in the final preparation stages for implementation, which means we are processing our first migration batch of 125 packages and 6 terabytes of material total in our test environment to ensure that there's no unforeseen errors before we send it into our production environment. Once this is completed, we are projecting that by October, the system will go live. We will be training our stakeholders and preparing new packages to be ingested into the system alongside legacy content. We have 3 customized and automated processing configurations set up. The first for digitized material created in-house by our digitization unit, the second for all born digital material processed by our digital archivist, and the third for all of our legacy content stored in the LTO tape archive. Overall, we have had to disable specific microservices to improve our processing, such as ClamAV and bulk extractor. We do anticipate that the full migration of our legacy material will take us approximately 5 years to complete. This has been a project that began conceptually in the fall of 2023, so 2 years later, we're nearly there.
So, what have we learned? First, digital preservation never ends. We must continuously update and modernize our digital preservation standards and infrastructure as technology evolves and digital records become more prominent. Secondly, a standardization of language, documentation, and practices is key to foster the collaboration that is the backbone of digital preservation. We also learned that IT units, like our libraries IT, are essential partners in this collaboration as they are critical for the implementation and testing of technology that our digital preservation practices will rely on. Lastly, advocating for your projects and generating buy-in from your leadership is important for building sustainable endeavors that are backed by long-term support. Thank you for attending our presentation. We'll be standing by for any questions, and these are our emails in case there are not enough time to answer all of them. Thank you.